Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going to be discussing how to find the derivative using the definition of the derivative, the limit definition of the derivative, or what's being called here in this problem the two-point slope limit method to find the derivative. So let's jump right into this. So the idea of a derivative is finding the slope on a curve at a single point. And one of the ways that we can do this is to take 2 points on that curve and then bring them closer and closer to one another and take the limit as one point approaches another point. So here's what we're going to do. So we're going to have 2 points. So we'll have the point A, comma, f of A, and the point B, comma, f of B. And let's find the slope in between those 2 points. So the slope is the difference between the y values. It doesn't matter which way you go, but I'll do the normal second minus the first, all over the difference between their x values. It's b minus a. So let's figure out what f of b and f of a are. And f of b and f of a are just plugging in b and a into our function. So f of b is equal to 4b cubed minus 3b squared. And f of a is equal to 4a cubed minus 3a squared. So let's go ahead and plug that into our slope function, and let's start to take a look at this. So we get 4b cubed minus 3b squared minus, I'm going to put brackets around everything, minus 4a cubed minus 3a squared. And then that's all going to be over b minus a. So what's typical with a problem like this is that we're looking to factor polynomials and come up with a common term. And usually the common term is going to be the term on the bottom, the b minus a. And that's what will happen here. So what I want to do is I want to distribute this negative, this minus sign to both terms, and then group the powers together. So I'll group the b cubed and the a cubed, and I will group the b squared and the a squared. So I get m equals 4b cubed minus 4a cubed minus 3b squared plus 3a squared all over b minus a. So that's starting to look like maybe I'm going to get the difference of 2 cubes in the first 2 terms there and the difference of 2 squares in the second 2 terms. To help us to see that a little bit better, I'm going to factor out the 4 out of the first 2 terms. And then I'm going to factor out negative 3 out of the second 2 terms. So we get 4 times b cubed minus a cubed minus 3 times b squared minus a squared. Because to factor out that negative, the signs have to change. All over b minus a. So there's my factorization. And now with the 2 parenthetical terms, I have the difference of 2 cubes and the difference of 2 squares. And both of those are factorable. I'm going to put down what the factorization is. If you need to, you can go back and find information on how to factor the difference of cubes, since that's a little bit harder and not well known. But it's definitely something you want to memorize, definitely something you want to have in your toolbox. So we get 4 times b minus a times b squared plus ba plus a squared minus 3, and then this is the difference of squares, which should be a lot more familiar to you since it gets used a whole lot more, all over b minus a. So now you look at this and we have b minus a in common now with both terms. Terms being those long strings. So I'm going to factor a b minus a out of both of those terms. You don't have to do this, but just for sake of clarity, we'll do that. So pull out that b minus a, and then we get 4 times b squared plus ba plus a squared minus 3 times b plus a, and this is all over b minus a. So then the b minus a's cancel, and then we're left with just a pair of binomials, or not binomials, polynomials that are being subtracted. So now we need to turn this into the derivative. And the derivative is essentially the limit as one point approaches another point. In other words, we can just think of the x values. We can say as b approaches a of m, our slope. And we've done all the work now to make something nice for m. You could also think of this as the limit as b approaches a of f of b minus f of a all over b minus a. That's another way to look at it. But let's go ahead and plug in m as we've got it. You can distribute the 4. You don't have to. Okay, now I'm sending b to a. So for every b that I see in here, I can plug in a. I'm allowed to do that because that will give us no problems. Won't let us divide by 0 or any other illegal move. So combining like terms and getting everything combined, we get 12a squared minus 6a. And if you use the power rule for differentiation, you should get the same answer if you go and double check. So that's it. If you have any questions, feel free to put them in the comments below. And if you ever have any other problems that you'd like to see done, please put them down there as well. Thanks, and I'll see you on the next problem.